This 8?
Technically 6. And what?
I was going to say.
6 right.
Is it this one?
No, but that's kind of what makes it interesting. That's kind of why I want to watch it. You know?
Alrighty.
You have to say your introduction.
Hello, everybody.
In the camera.
Well, he would have this bad right here.
It's good to be taken.
There you go. He's enjoying it.
Yeah, it might be. Okay, welcome to calculus. I like that a lot.
Alrighty. Is there going to be a theme song? If you're listening to me now out there, this is a calculus class, just to let you know. All right, what we want to do here is we want to get it into a form in which we can integrate where we're going to have a link. I need to move? Oh. Well, somebody has to tell me this.
We do.
Yeah, usually you guys do. Is that better? Yes. Alrighty. So if you notice, we have an even secant power. So what I'm going to do is I'm going to take a secant squared out. And that's going to be, this part here is going to be our link. Because that's going to be part of the chain rule. And it's a link to tangent squared. Or to tangent, excuse me. And so I'm going to rewrite this as secant squared 2x. And then I want to convert the rest of this to tangent.
Is that 2x in the parentheses?
There's a 2, yep. So I'm going to have 1 minus secant squared, is that correct? What did I give you on the notes before? I had this, right? Didn't I have sine squared x plus cosine squared x equals 1, and then I divided by cosine, and I got tangent squared x plus 1 equals secant squared?
Yep.
And so 1 minus, or secant squared minus 1, I got it backwards. Secant squared tangent squared, like I said, of 2x plus 1. Yeah, the pressure of being live. Secant squared 2x dx. So now, I'm going to break this into two integrals. And I'm going to call this the tangent of 2x, that quantity squared, secant squared 2x dx. So this is the link to the tangent. And what I mean by that is the derivative of tangent is secant squared. And I'll raise that up. Is that a little bit easier, Flora, to see?
Yes.
Okay. And then I'm going to have plus. So I'm distributing the secant squared to the 1. The integral of secant squared 2x dx.
Why did you square the tangent 2x plus 1?
I removed the secant squared and replaced it, substituted with tangent squared of 2x plus 1
Okay,
because...
I saw that. I was just confused as to why like the tangent 2x was squared, but it's just because you rewrote it. So you
Yeah, I just rewrote it.
Okay.
Because what I'm going to do is I'm going to reverse...
So it's like you just took secant squared of 2x times.
Okay. So I'm just going, once I get it in this form, I'm almost ready to reverse the power rule. Okay? Now, the tangent, the chain says the derivative of tangent is secant squared. But I also have to take the derivative of 2x since it's in parentheses. So I need a 2 right here, which means I need to have a half here. So now I'm going to have a half times a third. The third comes from reversing the power rule of the tangent of 2x. All of that raised to the third power. So there's the reversing of the power rule of this. Plus the antiderivative of secant squared. Well, again, I got to have the derivative of 2x in this integrand, which is going to be 2. So I'm going to also need to place a 1/2 out of here. So that's going to give me 1/2 the antiderivative of secant squared, which is the tangent of 2x plus c. So my final answer is 1/6 the tangent of 2x, that cubed, plus 1/2 the tangent of 2x plus c. All right? So you can see the process is kind of the same. You're trying to create the derivative and then reverse the power rule, almost for every single one of these. This one, it says use integration by parts. What should that look like? I'm going to break it down like this and see if you can tell me. I'm going to have a secant squared x. What am I going to do with that? Am I going to take the derivative of that, or am I going to take the antiderivative of that?
Derivative, is that easier?
Well, do you know the antiderivative of secant squared? Do you know what the derivative, do you know what secant squared is the derivative of?
Yeah.
Tangent. So what I'm going to do is I'm going to integrate this one. So v is going to be the tangent of x. Over here, yep, I'm going to let u be the derivative of secant. Now, anybody remember yesterday what the derivative of secant is? Yeah, that's exactly correct. Secant x tangent x. So using integration by parts, I'm going to multiply u and v together. So I got secant x tangent x minus the integration of, what am I going to get here?
Secant x tangent squared x.
Secant x tangent squared x dx. So how should I do that? Well, I'm going to break it up so it looks like this. Secant x times secant x tangent x dx. Why? Oh, I'm doing that wrong, aren't I? How should I break this up?
1 minus secant. No, yeah.
So take secant x times 1 minus what?
Secant squared x. No, or is it secant
That's the other
squared
way
x
around.
minus x? Secant squared x minus 1.
Yeah. Secant minus 1.
Okay, now what am I going to do with that? Oh. I'll get secant cubed x minus secant x dx. Any ideas?
We take out a secant squared. No.
Have we done this one before?
We have to go through it again.
Pardon? Pardon?
We already did.
Never mind.
So when you break that up into two intervals?
Well, that's what we're trying to find originally, the secant cube. So once you plug it back in.
Well, yeah, I mean, this is something that's original. So this is what I was thinking that we could perhaps do. And we know it's equal to this. Because this is where we started.
Would it be minus?
This right here, well, I got a minus here, correct?
Okay.
And I got a minus here, so that's why I changed it to a plus.
And that equals secant
Cubed x, so I mean I could move that over, but then I
Isn't
still
it
have...
3?
What?
Isn't it 3? Yeah.
Is-
Is that a 2 or
That's
a
a
3?
cube.
That's a cubed right here.
Okay.
But then I got to be able to integrate, what's the derivative of secant? Oh, the antiderivative of secant. I think this is something we're going to come back to.
Okay.
All right? Let's look at 10 and let's look at 11 because I want to give you some time to work on it. And then I'll come back and I'll talk about that one.
Okay.
Yeah. Okay, so on number 10 here where it says, when none of the above guidelines apply, convert to sine and cosine. So if you take a look at this, this can be written as 1 over cosine x, and this can be written as cosine squared x over sine squared x dx. Do you follow that move? I have 1 over tangent squared, which is cotangent squared, which can be written as cosine squared over sine squared. And then I can simplify it in this form. I have the sine of x to the negative 2 power times the cosine of x dx. Why did I choose to do that? The chain rule, because the derivative of sine is cosine, correct? So now I got in a form in which I can reverse the power rule. So I'm going to have a negative sine of x to the negative 1 power plus c, or the negative cosecant of x plus c. I see a few questions there. A negative 1 over the sine of x plus c, which gives me that. Is that better? All right. You may see this. More than likely, this will not be on, this one will more than likely not be on the AP test, but you might see it next year in college if you take a calculus class. And what this is if you have any of these are 3 possibilities. And this is something like if you have the cosine of 3x times the cosine of 2x, you can write that as 1/2 the cosine of x plus the cosine of 5x. Now what did I do with that? I take a look, and this is 3 and this is 2, and what I do is I subtract them and then I add them. And in this case, in all these, m has to be bigger than n. So you never get negative values. That's what I'm trying to say. So you can break it like this. And likewise, if I have the sine of 3x and the cosine of 2x, I can write that as 1/2 the sine of x plus the sine of 5x. And if I have this example, the sine of 3x, the sine of 2x, that can be written as 1/2 the cosine of x minus the cosine of 5x. I never ever remember those. I always have them somewhere in my notes. And if I see them on a test, I make sure those are the first 3 things I write down. Again, you'll have it on a quiz. You won't have it on a test for me. All right? But I'll have it on the quiz tomorrow.
You'll have it.
Yes?
Will we be able to use notes on
Oh,
this?
every single time. Okay. So which of these am I going to use? I'm going to use line 1, correct? So this is going to be 1/2, and I'm going to integrate this. So I'm first going to, I'll write the integration symbol. And it's going to be 1/2 the cosine of what?
Cosine of
What is it? Just x. It's just going to be 5 minus 4. Minus the cosine of what? 9x dx. So now you can break this up into 2 integrals. And you have 1/2 the integral of cosine of x minus, or excuse me, dx, minus the 1/2 the integral of the cosine of 9x dx. Which simplifies it greatly, doesn't it? So the antiderivative of cosine of x is what? So I have 1/2 the sine of x. Now the only thing I need to do here is I need to have a 9, correct? Because of the chain rule. So I need to have 1/9 here. So I'm going to have minus 1/18 the sine of 9x. So it's a pretty slick, oops, plus c. It's a pretty slick rule. And so it's kind of a handy tool. It's kind of like having a ball peen hammer in your toolbox. For those people that like ball peen hammers, it's really useful. All right.
Why is a ball peen hammer better than a regular hammer?
Because it's more dense, and if you're a little angrier than normal, you can be a little bit more persistent and aggressive.
So like, whose skull have you smashed?
What? Pardon?
Whose skull have you smashed?
No one.
Yet. Yet.
You know what? I am a pacifist now. So.
Now.
Alrighty. That's it. We'll come back to the question that we got a little bit more difficult at a later time. It's not on tomorrow's quiz. All right? All right. Thank you for everybody out there. I hope you enjoyed this session. There's nothing more exciting than calculus. That's all I can say.
Three.